So since we are in week 4, we have completed the control statements for the past 2 weeks. Okay. So for today, this week, we'll be learning about pointer. So what is pointer and everything, I'll explain in a while with some examples. So it's a little complicated. Uh, yeah, pointer is a little complicated, but I think it shouldn't be an issue. As long as you can follow and understand the examples, it should be fine. All right. So let's start. So saying pointer, okay, pointer is a type of variable actually. The only thing it differs is that it points to another variable. So rather than the variable itself storing the information or the values, it actually becomes a pointer, hence the name pointer, where it points to other variables. Whichever variables that you like to set, you can set. Okay, so there are two things to remember when it comes to pointer. First is basically this ampersand. Do keep in mind this is similar that you use when you perform scanf. That I did mention that it means you can actually point or show to the address. So yep, the ampersand is used for the address, similar to scanf. And the new thing that you will be learning for today is this, the asterisk. So whenever you declare a variable and you put in the asterisk symbol in the front of that variable name, automatically that variable will become a pointer. All right. So let's take a look. So the ampersand is for the address and the asterisk or the star is for the pointer. So what really happens is that when you declare a normal variable with the name var, okay, uh, just visualize it as in a box. So this box, the name is var or the variable name var. Okay, so each of these variable will have their own address. So what does this address mean? It's basically the address in the memory of your computer or whichever PC, mobile device, any system that you're using. You have the random access memory, right? The RAM. So in the RAM, in the physical part, you have an address to let the system knows that where's the information stored. But of course, you don't really actually set this address because it's automatically generated by the program itself. So you don't have to worry about that. But just remember that every single variable has its own address to determine its location. Okay. So the content inside this box will be the values that you store or assign to that variable. So that's for normal variable. So when it comes to pointer, you will declare this variable name ptr, and when you use the asterisk, this ptr variable will be converted to pointer. So what it does, or what's the difference between pointer and the normal variable, it's the same actually, except for pointer variable, the values that it store is actually the address of the variable that it is pointing to. Rather than storing its own values, it is storing the address of the variable that it's pointing to. But of course, since this ptr variable is a variable, so it will have its own memory address. Okay. Don't worry if it's a little confusing. I'll show you an example in a while to differentiate and determine this variable and the pointer. So that's the address. So how do you define or declare a pointer? You put in the data type, put in the asterisk symbol or the star symbol, and you come up with your variable or pointer name. So it is same as declaring a normal variable, except by adding this asterisk, you are actually telling, okay, this will be a pointer. So when you do that, automatically you'll create a box. This is just for visual, it's not physically created. This is for you to visualize. So it will create a box which is with a variable or a pointer named PTR. It has its own address, but it's empty right now because we haven't assigned for it to point to any other variables yet. Okay. So how do you assign or do the declaration? Okay. When you look at normal variable, integer x, you create this. Okay, the variable name is x. It has its own address. Say if there's a semicolon here, right? So it will be like this. But then once you put equal sign, you are storing this value 547 into this variable. So what happens is 547 is stored inside. Okay, so when you put a pointer or create a pointer, the declaration is pretty much like this. Integer, the variable name of the pointer, equal to, you have to give the address of the variable that you want this pointer to point to. That is why we are using the ampersand. So when you put ampersand x, x variable as this address, right? So by using this ampersand, you are going to send the address value to this pointer. So when you run this line, the address of x, which is 4000, will be stored inside the pointer variable. Okay. So this one you can go on, you can check on the slides. Okay. And here's some example which for you to check on later because the answer is already here. So I'm going to jump into code blocks to show you how does pointer work. So, okay, code blocks. So we'll start by creating a project. Type console, C programming. So lecture week 4, pointer. Okay. We don't need this. But let's keep this as a template. All right. Hopefully you guys can see my screen. Okay, we will start with the basics. No, you can type this later. All right. Say when we declare a variable number, this is how we do normal variable declaration, right? So it becomes, okay, just a variable number, type integer, and then we assign some values for this variable number. So let's assume 9. So what happens now is this variable number has the value 9. So how do we check? Of course, by doing printf. So the value of number. Okay, so let's output the variable number. Okay, so let's compile this and run. We have this variable number declared as integer type, and we store or assign the value 9 to this variable number. So when we print out, we get the value. Okay, so this one you guys are already familiar with. Okay, so now next, before we jump into pointer, as I mentioned just now in this slide, each of the variable have its own address, right? So let's take a look or check out the address of this variable. So how are we going to do that? It's easy. Let's copy this. We'll be using the same code. So rather than value, we want to output the address of the variable number. So then new line. Okay. So if we give this variable number, it's going to give the value. But when we put in the ampersand symbol, we are actually triggering to get the address of this variable. So if we run this, build and run, we'll be able to determine the address of that variable. And don't worry, if you try this in your computer, you will never get the same numbers or values as seen in my screen, because every computer, every device has its own memory block, the size, and of course the compiler, everything, and the OS will assign its own address. So this number will be some random number. Okay, so no worries on that. So this is basically the address of this variable number. Okay, so that's the address. Okay, if you want to visualize this, here's an example that I like to show. Assuming, okay, we're going to convert this information into this example here. So let's assume this is the variable. Okay, so when we declare integer number, so we declare a variable called number in this green box. Okay, and automatically it will create an address. In our case, this is the address, since we already printf, so we know that the address of this variable is 6356732. Okay, and then the value that we assign or initialize this variable is 9. So 9 is here. So this is how it looks like when you do a variable. Okay, so let's put this aside and let's move to pointer. So what's the difference? Okay, for pointer, you have to declare with the asterisk. So integer, let me say my pointer name would be my pointer. Okay, if I leave it as it is like this, it's just a normal variable. But then when I put the asterisk in front, I'm declaring this variable as a pointer. Okay, so when I do that, let's do visualization here. Okay, so this is for the variable and this is for the pointer. So what I've done here is my pointer. Okay, this is the name of my pointer. Currently there's no values here and we don't have any address, so we are not sure on the address. Okay, so when I do integer asterisk my pointer, I'm creating an empty variable with a pointer type. Okay, name my pointer. And what I'm going to do is I'm going to set this pointer to point to this variable. So how am I going to do that? You have to do this, which you take the pointer variable name and you assign it to the address of the variable that you want to point to. So in our case, what I'm going to do, take the pointer name, okay, and then assign it to the variable that we want to point to. But it's not just as that, but you have to tell that since you are giving the address, so you have to do this. So when you do this, what happens is you are setting this pointer to point to this variable number. Okay, so when you do this, what happens in the visualization is you already have this, you put it to point to this number. So it will point to the address of the variable number. In our case, it's this. So when I do this line number 11, this is what happens. Okay, so this pointer is going to point to this address, which is here. So it will be pointing to this variable. Okay, now this is on the visualization. Let's take a look on the coding. So now we have seen the value of number. We know the address of the number. Okay, now let's check out the address of the pointer. So what I'm going to do is copy this, paste here, address of my pointer. It's the same. When you check the address of number, you just put the ampersand. In our case, when you check the address of the my pointer, you do the same. Let's build and run this. Okay. So if you take a closer look here, you'll notice that the address is different. So the number variable is stored in this location. The my pointer variable is stored in this location. So now we know that the address of this pointer variable is 6356728. Okay, so it's just nearby, just beside, few blocks besides this. Okay, so now we already got the address. So what I want to view, what else? I want to check whether is it true this pointer is actually pointing to this variable number. So how do I check that? Copy. So I want to see the value or pointer of the my pointer. So is it pointing to the number? You just have to put this asterisk my pointer. So when you call the asterisk my pointer, this will give you the value to whichever this pointer is pointing to. In our case, it's pointing to number. So since it's pointing to number, you should get the same value as stored in number. Okay, let's take a look. And there you go. So the value of the variable number is 9, since we already initialize or assign here. And then we check the address by using the ampersand. So we know the address of the variable number is this. And then we check the address of the pointer we created, and we know that it's stored in this location. Now, when we call in the pointer itself, do keep in mind the pointer initially doesn't store any values, it just store the address. So when you call asterisk my pointer, it will go and retrieve. Since it's pointing to number, it will go to number and retrieve whatever value that number is being stored. So at this moment it's 9. So what if I change the values here for number? Okay, let's take a look. Pointer is going to do the same job. It's still going to point to the variable number. So if I change this to say 65432, okay, 65,432. Okay, when I execute, okay, take a look here. The pointer is still going to give the same value. Why? Because the pointer was designed to point to this variable. In our case, to the variable number. So whenever you change any values to this variable number, the pointer will still display that number. So that's the purpose of pointer actually, to point to a variable. Okay, so now We already got the address. But let's confirm. From this, let's confirm that the pointer is actually storing this address. So now we know here the value initially. Oh, I will change it to. Let me go back to a simple one. Say 10. Okay. Okay. This is the output from the code. Let's visualize this. So we have a variable called number. Okay, this is a small n. Variable called number with this address 656732, and it has a value of 10. So when I create the my pointer and I point to this variable number, it's going to store the address of number, but it has its own address, which is this. Okay. And when we call this pointer, it will point to its value 10. But now we want to know, is it true that this pointer is storing the address of number? So how do we check that? We'll go to decoding. So this for value, this for address, this for address. Let's rearrange this. So we call the pointer first. This will give you the value, okay? And then we call the address, which it will give you this value in the blue box, okay? And now we want to call the content to verify, is it true that this pointer is storing the address of this variable? So how do we do that? This is for us to check, okay? If you put the ampersand, it gives you the address. If you put the asterisk, it gives you the pointer value. But if you remove both together, it gives you the value that it is being stored at this moment. So now this line, the value stored in this my pointer. So I should get exactly as this. Okay. So let's run. So let's compare. So the value for the number 10, the address for the variable number is this. And then when you call the pointer, my pointer points to number. So it's giving the value that is stored here, which is 10. And then when I call the address for my pointer, which is using the ampersand, I get the address, which is in the blue box. Okay. And then when I remove the ampersand and the asterisk, I should be able to get the content. And if you take a closer look, I get exactly same. So the variable my pointer is storing the address value of this variable number 656732. Okay, in your case, these values will be different. If you run it in your computer or online GDB and so on, you will get different numbers. Okay, but don't worry, this representation will be always the same, which means whatever value for this blue address for this variable number, once you do the pointer assignment, you will get exactly same. Okay, there you go, complete chapter pointer.